In this video, we will talk about how to find the x and y-intercepts of a rational function. So to find the x-intercept, we set y equal to 0 and we solve for x. To find the y-intercept, we set x equal to 0 and solve for y. So I have a few examples for us to work through here. Let's check out the first one. Let's say we have y is equal to 3 plus 5x divided by 2 plus 4x. So first, let's find the x-intercept. Remember, we set y equal to 0, so we'll say y is equal to 0, and we solve for x. So over here, if we set y equal to 0, and we say 0 is equal to, in order for this right-hand side to be equal to 0, the numerator must be equal to 0, because 0 divided by anything is 0. So really, we just need to focus on the numerator and say 3 plus 5x must be equal to 0. And now we need to solve for x. So we can subtract a 3 from both sides. So we get negative 3 is equal to, these 3's go away, 5x. And to solve for x, we simply divide by 5. So we get x is equal to negative 3/5. So let's write that over here. X is equal to negative 3/5. So the x-intercept we can write as the coordinate pair negative 3/5, comma 0. Now let's find the y-intercept. So remember, for the y-intercept, we set x equal to 0 and we solve for y. So let's do that. So we get y is equal to 3 plus 5 times 0 divided by 2 plus 4 times 0. So notice both of these terms go away since they're multiplied by 0, and we're left with y is equal to 3 halves. So we get y is equal to 3 halves. So the y-intercept we can write as the coordinate pair 0, comma 3 halves. So that's how to find the x-intercept and the y-intercept of this rational function. Well, let's try another example. Let's say we have y is equal to 5 over x plus 10. So to find the x-intercept, we can set y equal to 0 and solve for x. So if y is equal to 0, we'll say 0 is equal to, recall, we only want to focus on the numerator, because if the numerator is equal to 0, then this whole expression becomes 0. So we have 0 is equal to 5. Well, notice this can never be true. So what that means is there is no x-intercept. Let's write that right here. No x-intercept. Now to find the y-intercept, recall we set x equal to 0 and we solve for y. So let's do that. We have y is equal to 5 over 0 plus 10. So y is equal to 5 over 10, which we can reduce to 1/2. So when x is 0, y is 1/2. So we can write the y-intercept as the coordinate pair 0, comma 1/2. So we found that there was no x-intercept, and the y-intercept is 0, 1/2. Okay, let's try another example. Let's say we have y is equal to x squared minus 9 over x minus 1. So to find the x-intercept, we will set y equal to 0 and solve for x. So before we set y equal to 0, notice that we can factor the numerator. So actually, x squared minus 9 can be factored into x plus 3 and x minus 3. And it's important that we factor both the numerator and the denominator if possible before we actually search for the x and y intercepts, and we'll see why in a second. So we said set y equal to 0. So remember, when we set y equal to 0, we need to only look at the numerator, because if the numerator is equal to 0, then this whole expression is equal to 0. So notice that we have 0 is equal to x plus 3 times x minus 3. Now, this right-hand side would be equal to 0 if either of these expressions are equal to 0. So what we can do is say set x plus 3 equal to 0 and set x minus 3 equal to 0 and solve for x. So in this side, we can solve for x by subtracting a 3, so we get negative 3 is equal to x. And on this side, we can add a 3, and we can say 3 is equal to x. So this whole expression becomes 0 if x is equal to negative 3 or positive 3. So let's write that up here. X is equal to 3 or negative 3. So in this case, there are actually two x-intercepts. It's negative 3, comma 0 and 3, comma 0. So there are two x-intercepts in this example. Now to find the y-intercept, we set x is equal to 0, and we solve for y. So if we do that, let's see what we get. Y is equal to x squared, so 0 squared minus 9 over 0 minus 1. Well, 0 squared, that's just 0. Minus 9 is a negative 9. So we have negative 9. And in the denominator, we have 0 minus 1. That's negative 1. So negative 9 divided by negative 1 is just a positive 9. So y is equal to 9. So we can write our y-intercept as the coordinate pair 0, 9. So we found our two x-intercepts and we found the y-intercept. Okay, let's try one more example. Let's say we have y is equal to x squared minus 6x plus 8 over x minus 2. So to find the x-intercept, we will set y equal to 0 and solve for x. So 0 is equal to, and once again, we're just going to focus on the numerator, because if the numerator is equal to 0, this whole expression is equal to 0. Now notice that the numerator can be factored. So we can ask ourselves, what numbers multiply to 8 but add to negative 6? Well, that would be negative 4 and negative 2. So we can actually write this as x minus 4 and x minus 2 over x minus 2. Now you'll notice that there's an x minus 2 in the numerator and the denominator, so these will actually cancel out. So we're left with 0 is equal to x minus 4. So let's write 0 is x minus 4. To solve for x, we can add a 4 to both sides, and we get 4 is equal to x. So let's write that up here. X is equal to 4. So our x-intercept we can write as the coordinate pair 4, 0. Now to find the y-intercept, we set x equal to 0, and we solve for y. So over here we saw that this whole expression can be reduced to just x minus 4, since the x minus 2's cancel out. So what we get is y is equal to x minus 4. If we plug in a 0 for x, we get y is equal to 0 minus 4, so y is just negative 4. So we'll write that right here. Y is negative 4. So the y-intercept can be written as the coordinate pair 0, negative 4. So those are our final answers. The x-intercept is 4, 0, and the y-intercept is 0, negative 4.